Hi, everybody. Welcome to another Tuesday Topics with Alum. Thank you all for tuning in this week and every other week. I know we have some new faces and familiar faces, or should I say screen names. I want to say thank you specifically to our alum this week, Alon Grinshpoon, who is such an active alum with the CS department. You might have seen him with our How to Make the Most of Your Virtual Internship panel earlier this summer. And I was really excited to have him talk then and again now a little bit more about his own experience with Echo and just AR, VR, and that entire world. I know a lot of our students are very interested in this work, and so I'm excited to have him talk to you guys today about this kind of work that he's in, and maybe some of his entrepreneurial endeavors himself, right? But I'll turn it over to him. As always, feel free to send me any of your questions directly to me if you want me to ask them on your behalf. Anonymously, and as you might see, we are recording the sessions starting with this one for the Tuesday topics. So if you guys need to leave early, please send me an email and I can send you the recordings afterwards. But other than that, I guess we are done with intros and I'm excited to hear the presentation.
Love it. Thank you so much, Ivy. So excited to be here. I'm going to share a screen. Really great connecting with you all during these weird times. Hopefully you're able to see my screen. Give me a thumbs up if you can. We're going to talk about emerging technologies today. We're going to talk about augmented and virtual reality. We have a lot to go through. I'm going to tell you a little bit about myself and the company and our entrepreneurial journey, but it's really about exposing you to all these amazing, amazing new technologies out there that I got exposed to them during my time doing my master's at Columbia University. I went through the ComSci program, which was amazing and really a life changer for me. So introductions, hello, I'm Alon Grinshpoon, founder of echoAR. As I mentioned, I did my master's at computer science at Columbia University, specifically at Stephen Feiner's lab, Professor Feiner, if you've heard of him, at CEPSR. That was a transformative moment for me because that's where I actually got immersed in the world of augmented and virtual reality and realized that this is the thing I want to pursue. And Columbia was an amazing part of that entrepreneurial journey in a sense. I'm obviously a certified nerd because I also have my undergrad in computer science and electrical engineering, and I'm a big believer in augmented virtual reality. Our company is a cloud company, basically providing tools and network infrastructure for developers who want to build AR, VR applications at scale. We started the company right out of Columbia, so right after I graduated, I started the company with my co-founders. One of them is also a Columbia alum from law school. After that, we raised funds. We went through a really, really amazing entrepreneurial journey through VC funding and went through Techstars and got grants from Y Combinator and NYC Media Lab and Verizon. And went through all these entrepreneurial events that basically exposed us to this amazing world of emerging tech and AR, VR in general. I'm going to show today a few ways to interact with AR, VR, some live demos that you can interact with as well. We're going to talk about the history of augmented and virtual reality, and we're going to talk about use cases as well. So just to level set here a little bit, we hear these terms being thrown around a lot. What is augmented reality? What is virtual reality? So virtual reality is when everything around you is digital. You're fully immersed in a digital environment. Everything around you is a CGI, computer-generated imagery construct, and you're basically completely immersed in such a 3D environment. Your vision is obviously occluded with some headset. Sometimes it has speakers to also control what you hear, but you're basically fully immersed in such experience. As opposed to what we have with augmented reality or AR, in which you still see the real world, and the real world is being overlaid with 3D data and CGI imagery, and you're looking to the world through some optical see-through like glasses or like some kind of headset, or through a camera see-through like a mobile phone or a tablet. An amazing example to understand this is the amazing movie Space Jam with Michael Jordan, in which Jordan is being teleported into Looney Town. Everything around him is a cartoon, and he's again fully immersed in a 3D environment, as opposed to what we have later in the movie, in which the Looney Tunes comes to us, and we're able to play basketball with them. They're able to interact with Bill Murray in a real-world environment. So these are basically the differences. Real-life examples of that is something that you've probably known, like Pokemon Go. That's an amazing example of augmented reality. People are running around in the real world, interacting with digital monsters that are not actually there. As opposed to VR, we have a really popular game called Beat Saber, in which you're slashing digital cubes based on the music, but everything around you is fully digital. Another amazing example of augmented reality is my thesis back at Columbia University. So we took CT and MRI, converted them into 3D, and then put them on smart glasses for a physician to wear. That was an amazing experience. I was scrubbing into surgery at Columbia Medical, which was unbelievable as an engineer. Amazing experience, and basically allowed physicians to get an inside view of the patient's anatomy while they're doing the surgery. So they basically got this 3D map of the patient while they're driving catheter through their body or doing any other surgical procedures. That was an amazing transformative moment for me, but in order to achieve that, I had to do something that I really hate, and that's waking up early in the morning. I had to be at Columbia Medical 6 a.m. every day, and that was an insane hassle. All I wanted to do is just switch out 3D models, a heart to an aorta to lungs, stuff like that. And as an engineer, all I want to do is basically just manage and deliver 3D assets. And what happened if I wanted to work with Chicago Med? Do I have to like fly out to Chicago every morning to swap out 3D models? So that was a really big problem for me as an engineer. And when talking to other developers who build augmented reality applications for retail and gaming and shopping and data visualization, they all said the same thing. There's no easy way to manage and deliver 3D data. But if you think about it, companies have solved this problem for 2D. Companies built cloud platforms for web, later for mobile. So you're obviously asking, who's going to build that cloud platform for this new kind of emerging medium, which is AR, VR, MR, 3D, immersive, call it whatever. And you've guessed it, that's us. So we're that cloud platform for augmented virtual reality. And again, you can see how that problem that I had back at Columbia University basically propelled me to actually solve that in the real world. The way it works, and I'll share a demo that you can interact with as well. So that'll be like a really cool interactive part. But the way it works is the same way. You don't have to be a web developer to update a blog post. You just drag and drop an image or video. Or if I'm in New York and you're in California and we're both watching an episode on Netflix, we automatically get the best streaming experience. We translated these concepts into augmented reality and virtual reality, providing you a way to match 3D assets to real world target and get the best 3D streaming experience. And we're going to see in a sec how that looks. So this is what we've built, this really cool management system for 3D. And again, it was like an amazing experience to go through Columbia, finding that niche that I'm actually really passionate about, and then creating a product around it. You can actually register for that for free on our website if you like. And I'm going to show you right now how to play around with 3D models, what does that entail, and how does that look? And after that, we'll transition into like the history of AR, VR, and how we got the point that we have these technologies that we have so far. So if you still see my screen on the left, you should see your content management system, and on the right, you're going to see my phone. I'm going to start with something super simple. I'm going to upload a fan favorite 3D model of the Empire State. We're all in quarantine right now, so I'm going to plug that 3D model because I can't go to the Empire State, but the Empire State can come to me. So let's see how that works. So I'm taking that 3D model that is very fitting for 3D printing as well, posting it to our cloud, then we convert it so it works on any device. Once that's done, I'm able to open this app. It will stream the data from the cloud to the device, basically allowing me to see the Empire State in my room. And in a second, I'm going to show you how you can see the same Empire State in your room as well. So I'm streaming the data from the cloud to the device. After that, that camera see-through, that camera opens up in my phone, and there you go. The Empire State is here with me, and I can walk around it. I can walk inside. Super simple. This is a mobile example of like a mobile app. But you can also do web applications. So for example, you can just stream it through a website. You don't have to install anything. We work with a company in the art space that wanted people to randomly walk in and just see 3D models. No worries at all. Let's see how that works. So if you want and you have a phone, you can scan this QR code with me. Just put your phone in front of this. Most cameras and most mobile cameras have a built-in QR code scanner, definitely on Android and iOS. It will redirect you to a website. You don't have to install anything. And if you put your phone in front of like the floor or some surface, you'll automatically see the Empire State in your apartments right now. So definitely check it out. All you have to do is just scan this QR code, and that should redirect you to a website, exactly what you're seeing on my phone right now. So we're able to see the Empire State on my phone. I'm going to press C and AR. And there we go. The Empire State is here, and I'm able to interact with it. I'm going to place it on the table. Perfect. Super easy. You can do the same thing with your cameras right now. Another example of things that we can do in AR is what you just saw is a segment in augmented reality that's called that's called surface detection. The camera recognizes a floor, like a table or a chair or a wall, and I'm able to overlay that with 3D content. What I'm going to show you right now is another example of augmented reality in which you're able to see 3D models overlaying some image. So what I'm going to do right here, I'm just going to scan the QR code. And again, you can do the same thing with your phones right now. And what's going to happen right now is that 3D model will overlay this image as opposed to being on the floor. That works really well if you have, for example, a business card that you want people, there you go. You have a business card that you want people to look at, and then it suddenly animates, or we have a video, or you can have a magazine that being literally changed completely by just putting your camera in front of it. So these are obviously like pretty cool use case of augmented reality, but you're limited only by imagination. And later when we talk about use cases, you'll see how many amazing things you can build with AR. But the cool thing about that, and look how cool this is, that you can automatically make it work from our cloud to any devices. So if your phone is in front of the computer right now, you should see the same thing that I'm seeing. And it's super easy, and it doesn't matter which device you're having. We just make sure to stream that directly to your device. The same way back at Columbia, I wanted to stream that to the glasses of the physician wearing the headset. You can also add videos. Maybe I'll do like a small video example. And then I'll just move on to some history about augmented and virtual reality. So let's see that. Let's throw in some video, and let's throw in some maybe specific image. Let's do that. And there you go. So same process occurs. Now we're just making sure that we're enabling AR through video and images, as opposed to what we had earlier, that are just like putting something on the floor. So let's see that. Once that is uploaded, I'm just going to do the exact same process that I did earlier. And again, you can do the same thing with your phones right now. Just scan that, and we'll automatically see your AR creation. So let's do that. There we go. And now this marker is going to be overlaid with some video in AR. Super, super simple. There you go. We can see a cartoon together, all in AR. So definitely check that out. Some other examples I can show, and later, again, we're going to dive into more and more use cases, but you can build, like, for example, a COVID visualizer in 3D, some avatar for remote training. You can do like a bunch of things like watching a video in like a living room setting inside your living room, or expanding on that and having some volumetric captures of a runner being engaged in augmented reality. We have a bunch of these things that we work with a bunch of companies that have different use cases, which we'll talk about later. You can build a cool freaking museum that basically shows you new images on top of the existing one and making them come to life. So we've seen how you can build things in AR like really, really quickly. Let's talk about how we got here. Like, how do we got to the point that you're able to build AR? And for that, we'll have to dive in and basically take a journey in time to the inception of augmented and virtual reality. So it all started in 1838 with this contraption. This is called a stereoscope, basically inventing the notion of tricking your brain through showing you different images. What we have here is two different images that are almost exactly identical, but they're shifted a little bit. Each eye gets to see one of those images, and then your brain interpolates that into a sense of depth. At the end, this is how AR, VR, everything is being achieved. Each eyeball gets a different image, and then we're able to get that sense of depth by faking it, by faking that feeling of immersion for your brain. But look how antique this looks, right? Like, but that was the inception of everything. A few years later, we had another invention by a pretty known guy named Thomas Edison, who created this cool kinetoscope that basically showed you a video in 3D. This is film that runs through your eyes and basically shows you two different images to each eye. Again, using the same concept that we saw earlier. After that, we have another cool example of a simulator. This is the first time that people said, okay, we're going to AR, VR, it's all about immersion. And these terms obviously did not exist yet. But this is all about immersion, and we're trying to create a simulator using gas to move the simulator, make it a little bit like to vibrate, to simulate some kind of you know, fighter pilot kind of scenario. This is the first science fiction work that actually talked about augmented reality, talked about what does that mean to have like some glasses that controls every sense that you have. And these works of science fiction are actually now a reality, and we'll see later how. The ViewMaster is something that probably some of you had during when you grew up. Again, the same concept, showing different images to different eyes. This is a really cool example of how this was back in 1938, was a insanely novel experience, showcased at the New York World Fair as like the most inventive technology. And now I just showed you, like 5 minutes ago, I just showed you a much more compelling example in your phone, like right now. So interesting to see how we were able to progress in such a short time. After that, that was the first head-worn display, the first actual headset that you can wear, and that will change your sound. Again, just 1960, that's not that long ago. A year after, motion tracking was introduced, basically allowing you to understand where the head is positioned. And you can see this guy's wearing a suit because like they thought this is a commercial-ready product that they can sell people. After that, we have the Sensorama, a really failed attempt to commercialize AR in the sense that you would sit in this chair and you'll feel like you're driving a motorcycle in New York. Again, New York has a big theme, and obviously a big thing with Columbia, but it's really interwoven with the history of augmented virtual reality. You're sitting here, that chair controls your sight, controls smells, controls sounds, to basically give you a full VR experience. But as you can see, it's pretty bulky. That attempt failed. The Sword of Damocles is actually one of the most famous ones when it comes to AR VR. This is the first AR headset that was literally had to be mounted from the ceiling with. Oh, I'm hearing some echo. If you can disable your mic, that would be great. I think it's coming from Gustav. So what we have here is basically. Yeah, so we basically have here is like, yeah, someone in the chat says like Clockwork Orange. Exactly. That was an inspiration for a lot of amazing works of science fiction, and a really, really good use case to show new novel ideas of human-computer interaction. Suddenly we're able to, with the same technique of putting different images to your eyes, understand the environment, interact with it. Instead of using a mouse and a keyboard, we're able to figure out these things through eyesight. So that was a really interesting and inspiring work of research. And we have, I think, a version of that in Finder's Lab at Epson. Later, another point of trying to commercialize VR. Now it's still images, still staying 3D images, but as you can see, that's not enough. But what was interesting in this work is that we had a really large field of view. Right now, when you're looking at the world, you have over 180 degrees of field of view because that's how we perceive the world. But that's not the case when you wear a headset. Like it can only control a specific section of your field of view. And that was the first one. We had like a pretty large field of view, like 90 degrees. That's basically showing, basically giving you like almost like a window to a virtual world. After that, there's a really cool human-computer interaction research that basically showed that you can control things with your hands. Like this is so insane that you figure out, okay, now that we have these headsets and now that we're trying to figure out how to interact with things in 3D, how do we translate content from 2D? How do we translate selection? How do we translate interacting with stuff? We're very used to using keyboard and mouse, but how do we do that in 3D? How do you select something? Do you click it? Do you speak to it? Do you look at it? And this was a really cool example of how you can use your hands to draw graphics and select them. NASA did like a really cool VR headset that basically used haptic gloves, and we'll talk about them later, but basically giving you some kind of virtual reality experience before virtual reality was even a thing. The term was not even coined yet. But that was a really cool example of, again, trying to push research to the limit and see how can we control people's perception. This is a classic example of something everyone needs to own. The Air Force tried to use this enormous VR headset to simulate the experience of being a fighter pilot. Really weird, obviously, and non-commercial. But again, trying to fit this technology into a really unique use case, that is something that is very inspiring. And the same thing happened with the Brits, who tried to do the same thing as the US Air Force, trying to create some AR VR experience through either a VR headset or an AR optical see-through, like these lenses that you see right here. And then we get to 1987. Finally, the word virtual reality is coined by Gerald Lerner, one of the founding founders, if not the founding founder of virtual reality. And 3 years later, we have Tom Cottle coining the term augmented reality. So finally, after years of research and years of all these amazing advancements, we get an actual formulation of these topics. And we'll see how that actually helped really propel the field. And we'll see that we're going to jump from the 90s to the 200s. And the literally the insane difference between what we had in the previous years. They had to put things on the wall, on the floor, and handle on the ceiling. Now it's going to be much more mobile. We're starting out with Virtuality, a really cool arcade game that introduces multiplayer. Suddenly, this is an arcade game. It has people interacting together in VR. Now, suddenly AR, VR are not a singular experience. You can have different people seeing the same thing. Very similar to what I showed you earlier, that I'm able to see the Empire State, but you're also able to see it, and you're also able to see it. Suddenly understanding that these technologies should be shared. And here we have a really cool computer interaction with the joystick, right? Really fitting with games. Cave is something that is pretty remarkable. This does not even use a headset. It's all projection AR. A lot of labs have that on site around the US. It's basically having a glasses that are being tracked by a camera and then projecting different images on a wall that change based on how you change your head. So like the more you move those glasses that you have in your head, that perspective changes to fit what you should be seeing. And that was revolutionary because that means that, again, you don't need to have a headset. We just project things on the wall and make sure that they match and trick your brain in that sense that you feel that you're in 3D. I tried one of those in a few conferences lately. It's pretty remarkable that almost like magic that the environment changes based on how you move. And this is basically how you perceived yourself, right? So this computer science interaction basically allows you to trick your own senses into feeling that you're fully immersed in 3D. Another failed commercial example was the Sega VR, another game console that at the end just materialized as an arcade game, but never actually got to consumers. But admit it, it looks extremely cool, has a visor, has headphones. This is what we expect from a VR headset. Virtual Boy was an attempt by Nintendo to give you some immersive gaming. Did not go that well, but again, they really focus only on images as opposed to videos and 3D environment, and that's what I believe tanked that invention. And then finally, 15 years ago, the early century that we're in right now, we have mobile AR. Finally, an example that you can use your phone to see augmented reality. This was research being done, basically allowing you to have a collaborative tennis game. The camera will recognize these images, very similar to what I showed earlier in the beginning, that the camera recognizes some QR code, and then you're able to play with it. That was a really cool research back in the day with Nokia that set the standard of like, okay, now we have mobile phones. Now we can connect data. Now we can stream data to phones. This should be the golden standard for AR/VR interactions. Right after that, in 2012, we have the Oculus Rift. This is the first major consumer-ready VR headset in market. And it was so successful in the sense that Facebook bought that company, and it's now a subsidiary of Facebook. They're doing fantastic work of like creating a headset that actually works, like actually allows you to immerse yourself in a 3D environment. And later we'll see how they evolved. But this was again like 8 years ago. What they have today is almost incomparable. And again, unbelievable that in such a short amount of time we got to these heights when it comes to augmented and virtual reality. Google Glass was a failed attempt by Google to create these monoscopic optical see-through, like literally a glass that you're able to see through it. It didn't work because, again, it doesn't give you that 3D representation because it's only one eye. So it would give you like some kind of a heads-up display that you're used to from games, of like a clock, but it didn't really work. And again, I think the reason was because it was just one eye. It didn't get you that 3D immersion feeling of having two images projected to both of your eyes. Google Cardboard was an absolutely amazing success as opposed to that. Literally paper being sold as commodity, and you can use that even today, and you can buy it on Amazon or eBay for like a few bucks. And it's unbelievable. This is like mobile VR, mobile AR being born. That you're able to stick your phone in front of your eyes. The phone just projects two different images to every eye, and there you go. And that was like a fantastic experience because I saw so many classes, even a class in Columbia that just has a bunch of those, and students can use them for education and for training and games. And that was a phenomenal way to show, oh my God, like even a cardboard is sufficient enough to propel us to the next level of augmented and virtual reality. After that, we had the attempt by Samsung to have something that basically sets the standard for mobile VR that didn't really materialize because people didn't want to drain their battery by putting it in front of their the front of their head when you can just buy almost like a game console standalone headset. But that was a really, really cool way to inject VR into the mobile space, because everyone already has a mobile phone. Now how can we take it to the next level? 2016, the HTC VIVE is being released. This is yours truly having his mind blown. I went to the Microsoft store at Fifth Ave trying the HTC VIVE for the first time. And that was the moment I was fully convinced that AR and VR is the most amazing thing. This moment in 2016 was the one that propelled me to apply to Columbia, to reach out to Professor Stephen Feiner, to talk to him, to make my research around AR VR, because I was so blown away by the experience. It was literally fully immersive, insane high-end graphics, controllers that allowed me to like draw things around in my environment. It was like a really, really unbelievable experience and really life-changing. And again, that's why I really encourage everyone, try using AR headsets, try interacting with them, go to those AR VR labs at Columbia once the quarantine is done, to just experience this. This is really magical and truly magical moments. PlayStation VR, another amazing success in the console wars, basically introducing VR to console gaming. What's cool about this from an interaction technique is that you see these light bulbs basically that you have to hold. These are the controllers that you're using, and the camera recognizes these lights as opposed to what we are earlier, like joysticks that you would move some kind of specific knob. Here you have lights being automatically captured by the infrared cameras on this device. Really cool, really useful when it comes to using your own console to power this kind of VR experience anyway. The Microsoft HoloLens, one of my favorite devices, came out in 2016. That was the Cadillac of AR. That's what you saw in my example that we worked with Columbia Medical. We would give these out to physicians that would wear them. It's fully standalone. It's wireless, it's tetherless, which means there's no like battery pack or some wire that I have to plug in somewhere. Completely wireless. I put it on my head and that's it. Literally just glasses. Unbelievable. It has voice commands, has hand traction, which really it recognizes my hands and I'm able to interact with them like we saw with the physician, basically touching the heart in real life. Like real life, right? But it has like a limited field of view. Like you look at the world through like these small lenses and basically giving you a window to the virtual world. It's about like being fully immersed in it. 2017, AR is mobile. Everyone in their phones has AR, VR capabilities. And that was just 3 years ago. Unbelievable. And if you think of things like Pygmalion Go and things we talked about earlier, these are a standard now. Like everyone has that in the phone. I showed you how you can stream AR into your phone right now. And you probably even know you have AR in your phone, but that is almost like a market standard by this point. Magic Leap is a really great company, raised a lot of money. They released the Magic Leap 2 years after HoloLens, and you can see that it's a lesser version of it just because it has a battery pack and it has like this controller as opposed to using your hands. They're pretty struggling, but they're really well funded and I'm sure they're going to do amazing things. Focals is a really cool company. It has offices in Brooklyn that you can actually go and buy these really cool spectacles. It literally looks like glasses and very similar to what the Google Glass tried to do. It shows you like notifications, shows you like a monoscopic display that shows you, oh, what's the time, directions, do I get a text or something like that. Backed by Amazon, and again, you can visit them in New York. What's interesting about them, that their human-computer interaction technique from, again, the emerging technology here is this ring that allows you to control things in AR. Raptor is another cool company that created this visor that gives you another head-worn display that shows you this the heads-up display of like some information about cycling, very enterprise, I guess, cycling focused. The same year, we got the Oculus Go, which is a remote wireless version of the first Oculus that we saw. You're able to deploy experiences to it, but it's not that, it doesn't have every degree of freedom. You can't completely walk around it, but that was a really cheap alternative to getting people to just buy VR. This costs less than a phone. A year after, we got Epson releasing glasses that are really industry focused, really all about enterprise use cases. But what the cool thing about this is, like, if you see it, like, it looks like glasses. We literally got to the point a few years later, and we started in 1838, right, with the stereoscope, and now we have this. Decade later, like, we see this amazing transition into something that looks exactly like glasses. The same year, we got the Vuzix. Again, you can see that limited field of view, but these glasses look pretty good, right? Like, this looks like vintage kind of glasses that you could wear, definitely. So that's another, again, ergonomics perspective that this tech has come to the point that it looks really, really cool. 2019, the Oculus Quest. This machine is amazing. We got wireless, and I have it right here. Actually, it's amazing. We got wireless, tetherless VR, all in one, which means you don't have to have a computer at all. Everything is self-contained. You put it on your head and it works. And that immersion feeling, that magical feeling is unbelievable. I definitely, again, encourage you to check out these devices either at like the Microsoft store on Fifth Ave or the AR VR labs that exist at Columbia, specifically the one at Cepster that I love the most. And check those devices out, because like that feeling of injecting yourself into a virtual world is unmatched by anything. This is like magic. That's how magic feels like. And you remove the headset that, again, can be used with your hands. You don't even have to have controllers. It actually recognizes your fingers. It's an unbelievable experience to see that how far we've come from where we started from. After that, we have the Oculus Rift, a high-end version of the Oculus Quest. This one is tethered to a computer because it needs that computer power for high-end graphics. But again, what's interesting here is like, look at the advancement that we've done in just a few years. Like the first example we saw in 2012, and now 7 years after, we have this high-end 4K example of VR almost lifelike, with almost lifelike graphics. And later, we're going to see some use cases of AR VR that will demonstrate how to use headsets like that. Vario is another really cool example of an AR VR kind of device that shows you both, that allows you to switch between AR VR through a camera see-through, which is really compelling, because with a low latency of that camera, you're able to just stay in the real world, but then click a button, suddenly you're teleported and suddenly you're back. Unbelievable experience, again, from that emerging human-computer interaction. It's unmatched. Google Glass made a comeback this year with some more enterprise solutions. Again, monoscopic experience, but I wish them all the best. And Nintendo, going back to the cardboard experiences that we discussed, look how easy this is. Like, you can just literally use paper to create amazing VR experiences, and use the Switch to just project 2 different images to each eye, and you're good to go. Unbelievable use case and very creative. The HTC VIVE is the newest version of the one that I was blown away by in 2016. And this one is a little bit lacking because it does need to be tethered if you don't have some adapter. But it has like insane visual, like 4K resolutions that are really, really exciting to see how you can literally see images that are like, almost like. Pygmalion is something really cool that I tried out at CES in Las Vegas this year. It has eye tracking. Think about it, like another cool way and another cool medium that you can define for human-computer interaction. Maybe I can select stuff by winking. Maybe I can select stuff by looking at it, almost like a telekinesis kind of thing. So really interesting that they incorporated that and setting the standard with other companies. Nreal is a really cool example of almost like, this is AR glasses that look exactly like glasses. This is yours truly trying it in Las Vegas. This one has a battery pack and it's tethered, but the ergonomics here, like, it looks like glasses. It looks really good. I saw the movie Avengers Endgame on these things for like 30 minutes. It was like, I was teared up. It was like so crystal clear. It was so immersive. It was unbelievable. And now, last but not least, the Microsoft HoloLens 2, a new version of the one that I discussed earlier that has better ergonomics, as you can see, eye tracking, head tracking, like all these different things inside, and a larger field of view. And this was actually released for purchase, I think last week, even though they said they were going to release it in July. But again, amazing piece, and you can buy all these things like right now. So that was a journey through history, a journey through time. We started in 1838, and now we're 2020. And again, it's unbelievable how we got from a wooden contraption to a fully fledged computer sitting on your head, projecting images into your eyes. But here we are. And now that we have these things, let's talk about use case a little bit. We love to say that we enable people to build experiences, like we mentioned the surgery one that we talked about, the Columbia project. But we can talk about ads and tourism and shopping and design and spatial recognition. And now we're going to dive into so many use cases. I'm going to run through them to leave time for questions. But let's talk about, like, what can you do with augmented and virtual reality? So we'll start with some use cases. Let's do that. This is the dystopian version of what we think AR would be, some hyper reality filled with content all around us, some Sims over digitalization. But the use cases that we have today is actually really far away from this, even though this looks pretty cool to me as well. One is obviously AR gaming. We talked about Pokemon Go. We talked about how you can interact with digital monsters in the real world with just your camera. VR gaming, we talked about Beat Saber, how you can just like play around with digital cubes that are not actually there and play with the music. Shopping is another cool example that we mentioned that, oh my God, we can visualize this box before we actually build it. AR gives us that look into the future. Art is an amazing use case for augmented virtual reality, basically allowing you to reinvent reality with digital concepts. VR art is another thing. This is the tilt brush that I mentioned that blew my mind the first time I used the HTC VIVE in 2016, allowing you to firebend, create things, draw things in VR. And that, again, that experience of persistence, of having content that you create in a 3D environment, it's unmatched. It's really magical. AR Magazine, The New Yorker, had a really cool campaign in which you put your tablet in front of the New Yorker, suddenly it changes, suddenly it animates. Really cool, right? Construction is obviously an insane use case. Put your phone in front of some floor plan, uses image detection to overlay 3D models on top of that. Zoology is another thing. We are used to carving out frogs in science class. Why do that when you have augmented reality? Same thing with anatomy. We saw how useful augmented reality is for surgery. Why not anatomy? Why not understand how the human body is actually built in augmented reality? And look how powerful this is. Like, we can do so many things that a textbook just can't. CHRM is obviously a big one, projecting 3D assets around us and like basically giving you this treasure hunt kind of experience. This is another example of the same thing I talked earlier about a cave, that projection method for for extended reality that basically tracks the usage, tracks these glasses and basically allows the user to get a feeling of immersion based on how they're moving. Really, really compelling. Advertising, obviously a big thing. Put you in front of some billboard, automatically we get new content on top of it, and you can localize that content. If you're looking at the same 3D model and at the same image in the US or the Philippines, you can get a different content through the cloud, for example. Filmmaking is a huge one. If you've seen the Lion King recently, that live action Lion King that was actually all CGI, that was such in VR. People would use the HTC Vive to basically plan the shots, plan how the camera moves, and basically automatically render that scene. The Mandalorian used really, really cool, compelling variation of AR VR with large LED screens that basically just project the environment in real time and move with the camera to basically give you that sense of 3D and faking that immersion. Remote assistant is a big one. There was amazing research being done at the Computer Graphics Lab at Columbia with Professor Feiner, doing a lot of amazing work around remote assistance, so definitely check that out. Remote work is obviously a thing. There's a company called Spatial based in New York as well. They're doing really cool things that you can actually use for free on any headset or any device to allow you in these troubling times to, have meetings in virtual reality. Training is obviously a big one. What we see here is that example of using your hands instead of controllers. Really, really compelling. Again, understanding what is the human-computer interaction that best fits this use case. And hand tracking could be that thing specifically. Marketing, obviously, right? We see a lot of campaigns of people just, scan this Dr. Pepper can and it will animate. This is a classic use case for marketeers to get more eyeballs. There's an insane wow factor around AR, VR. That's definitely not surprising to bring more and more customers in. This is obviously an obscure use case, but there you go, full immersion, feeling that you can fly. This has obviously more extra, hardware attached to it, but we're limited only by imagination. Like if you want to fly, you can do that in VR. Skiing is another cool thing. I think this is actually a little mocked than rather actually captured on the device. But this is a cool concept of giving you gamifying the skiing experience, right? Exercise is really cool. This is an example featured on Crunchbase that you're able to exercise, but also feel that you're running a NASCAR race instead of being on your elliptical or whatever. Navigation is huge. You can use your AR you can use AR in Google Maps like right now. It uses Google Street View and all these like all these scans I already have of the real world to figure out where you are, and then pinpoint arrows to show you how to go. Navigation and pathfinding. This is an insane field of research in augmented virtual reality to figure out what is the best techniques, how do we do that, how do we match it to the real world. I actually got lost in Boston because obviously it doesn't have the grids that New York is so famous for. And I use Google Maps, literally, that saved my day to understand how I can like go from my one meeting to another using just walking and having those directions. Spatial mapping is something that's pretty prevalent in the last few years, that people are trying to create a digital copy of the real world, literally a copy, like a digital twin. Google Street View is, again, that, let's say, inception of these things. So we have a scan of every corner of the world, and then we'll be able to inject 3D data on top of that. There are so many companies trying to do that. Niantic, who are doing Pokemon Go, just announced that they have kind of like some kind of form of this thing. This is a company called Scape. There's so many companies trying to like digitize the world and create that copy. Social AR is obviously a big one. If it's Snapchat, if it's TikTok, I'm a big fan. Social VR is also a thing. You can play poker with your friends. I know a lot of investors in the AR VR space, they actually have this like round table of poker they're playing all together in VR, which is pretty cool. You know, to lose money in VR, like actual money. A portal is obviously an amazing thing. Again, so immersive, keeps that amazing wow factor and magical feeling in augmented reality. Measurement is the utility-based use case. You can measure things in VR, in AR, literally the camera, because it triangulates all these surfaces, triangulates all the space. It knows lengths. It knows the height of a table. It knows everything about it. So you can use that. And there's so many apps that you can download right now in the App Store that just do that automatically with your camera. The AR surgery that we mentioned earlier, right? Like a really, really cool use case of augmented reality, literally life-saving. Surgical training, again, taking the same thing outside of the OR and having people train on that prior to going into surgery. Translation is a really cool one, using computer vision, pointing in front of this like road sign, and you automatically see its translation. This is a feature in Google Translate that you can try out like right now. Home design is obviously a big one. IKEA has this cool app. Lowe's, I think, has another app that you can like visualize before you buy, try a couch before you buy it, see how it matches. I would definitely recommend to check it out. It's really easy to, decorate your room like that. Time travel. This is actually a very weird example. This is a mom with her late kid basically having a birthday party with her after she was gone. Pretty creepy, I have to say, but obviously effective, right? Like that mom chose to interact with her daughter in VR and basically, talk to someone who's not there anymore. Copy paste was a really recent example that you saw people using your phone to copy paste something from the real world into a presentation. Another really cool use of computer vision and augmented reality. Multiplayer is obviously a really cool thing that you have to take into account, that you're able to synchronize devices, synchronize people in the same space to play together. An AR menu is another cool use case. You can just see something like a try before you buy, try before you eat, to visualize the menu. There's a few New York-based companies that do that. I think their name is Kabak, and they're basically having like really high-def images of food that you can just, try before you buy. And now we're starting to talk a little more about human-computer interaction, which is an adjacent field to what we were talking about AR, VR, like almost goes hand to hand, like pun intended, goes hand to hand with it. So hand tracking is one thing, understanding that this hand could be our controller as opposed to an actual mouse or keyboard or a joystick. This is a really cool example of how you can place menus with your hands. And again, this 10 years ago, you'd be burned at the stake by believing that this thing is a possibility, but now it's actually a reality. This is not witchcraft, it's actually a thing that you can implement in AR. Another interesting use case of augmented reality, of human-computer interaction here, is basically having the controller be this mocked wheelchair. And think about how immersive it is for someone who's like, for example, is not constrained to a wheelchair to feel the world through a wheelchair and get that experience, and basically bringing people together or gamifying that experience to somehow give people a sense of community together through that thing. And suddenly we have this, again, novel human-computer interaction with wheels. Who would have thought that that could be a really cool controller? now that we went through all these amazing use cases, let's talk a little bit about like pop culture and how they inject AR, VR, and then we're going to talk about some more future technologies, and then leave the floor for some questions. So movies and games are obviously saturated with AR, VR. Even in the AR, VR class that Professor Spiner is teaching, Minority Report is mentioned at some point because it has all these hands moving around and define interactions. All of these movies that you see right here that I'm obviously a big fan of, the Marvel movies, have some element of augmented reality. If it's a heads-up display, if it's a hologram, it's really amazing that this is the standard that we are setting up for ourselves from a cultural perspective, because this is what we expect to see. Like for us, it's really native to interact with the world as a spatial creature. We see that obviously, as I mentioned, in these movies, that you have a heads-up display or some kind of form of novel hand gestures. We see that in games all the time. All of these games are infected with just the sheer amount of AR, VR in every corner of them. For example, here we have a game that overlays content on top of that. That's a game called Horizon Zero Dawn that now gets a sequel on the PS5. Amazing game that, again, by design has this like AR navigation, AR overlaying of data visualization. Same thing with being human, solving crimes, you need AR for that. Batman, solving crimes, again, you need AR for that. Like suddenly in every game, some component of data visualization in the real world emerges. These are examples of games that you can actually download right now, and they have AR, like Pokemon Go, obviously, or Ingress, or Catan. They can just play in AR like right now. It's pretty compelling. I definitely suggest that you check it out. And I think for what we can sum up on all these use cases that we just talked and all these devices, that VR is very about immersion, basically teleporting you into a real world, as opposed to AR that's really around utility, giving you something in the real world that could help you perform a task better or achieve a goal much faster. So take those considerations in mind. VR and AR are not mutually exclusive, and they will, I mean, a lot of people will say that they'll converge at some point, like what I showed you with the Vario headset that has both. But the function here is pretty different. Like it's immersion and play as opposed to utility. Now we'll talk about some futuristic stuff. A lot of that I've learned from Columbia, but this is, again, like the cutting edge of the cutting edge when it comes to technology. And these are technologies adjacent to augmented and virtual reality that help us, I mean, continue that feeling of immersion. So 3D avatar is a big thing. This is research done by Facebook in which we're able to generate almost like lifelike avatars. Like this is a real person, this is an avatar, almost indistinguishable. Right now they have to do that with an insane array of cameras, but this is pretty cool. Like this is unbelievable that we're able to create digital copies of people. After that, we have the Omni track. I tried one of these at a conference back in California. This is really cool. Like you can walk anywhere. This is Ready Player One, ready today, that you can walk anywhere, and basically to get that feeling of walking around. And there's different approaches to that. This is an Infinity Deck. They have these like tracks that move around. But check out like CAT, for example, they have this like aluminum kind of style that you're just like drifting on with your shoes. Again, getting the same outcome, but different approaches for human-computer interaction. Here we have a different Omni track that basically allows you to do the same thing, just like in a different like plastic polymer kind of thing. Same thing here, but this one, because it's all in plastic, you have to like wear socks or whatever. But again, really, really compelling stuff that already exists that you can try out. Haptic gloves is pretty amazing. Like these ones look a little off because they had to integrate that with like existing headsets. But this one by Plexus looks pretty good. And again, what they do is basically provide you with some kind of feeling when you're touching something to basically mimic that real world feeling of touch. And that's unbelievable, but these things exist. They give you some resistance when you're touching something, basically, again, mimic that actual sense of touching. Haptic suits are a thing. They're mostly used for gaming at this point, but basically the same thing that we love in laser tags already exists in VR. This is a really cool suit called Tesla suit that I had the privilege of testing at CES. Again, looks pretty good, right? Like, think about it. Like this, the ergonomics here looks pretty unique. You could wear that without feeling awkward. You can actually look like a superhero. The way it works is, again, it has this sensational response, almost like, just like zapping you every time something happens in the virtual world. But that feeling, that is an essential thing for you to be fully immersed. touchless haptics are also a thing. I got the chance to play around with that at Columbia in a lot of conferences. Like if we have gloves and we have haptics, why not have touchless haptics? Like why not have just feeling the different touches from the air? And that's what we have here. This is an array of speakers, ultrasonic speakers that basically resonate to give your hands a feeling of something is burning, something is on fire, something is like electrified or whatnot. So you can see it right here. It identifies where your hands are and basically gives you that feedback to your hands. This is literally, should be sci-fi, but it actually exists. This is another really cool thing using the same tech of ultrasonic sound used for levitation. So basically we have resonance of ultrasonic sound having almost what I would call voxels, like, you know, those 3D pixels in the real world right here. So think about it. We have a pixel in 3D. Like we can create a construct of that. And now we have a dot. After that, we have a line. But how about creating a, I don't know, like a fully fledged dog, like a fully fledged 3D construct by having the right ultrasonic resonance. So this is pretty amazing. Awesome. So I really hope that all these things blew your mind. We talked about so many things. We saw entrepreneurial journey from Columbia to a company. We talked about how you can build AR, VR right now, and we shared a few cool demos live. We talked about the history of augmented virtual reality. How do we get to today? And we saw amazing use cases, both fiction and nonfiction, mostly nonfiction, of augmented virtual reality today, and a lot of adjacent emerging techs that are trying to help AR, VR become more and more real. As I mentioned, you can register for our platform for free on our website to do exactly what I did in the beginning of the workshop and play around with AR in your house. Like right now, while you're in quarantine, why not? You have no excuse like going to visit the Empire State as we just did. Yeah, thank you so much for this. This is my email if anyone wants to reach out and ask any questions. Happy to answer any questions right now. We have like 10 minutes to go. Thank you so much, Ivy. Thank you so much for everyone who has been here. And thank you everyone for like just trying to dive into this world of emerging tech and AR, VR specifically to really broaden your horizons. We were talking about a lot of things that a few years ago were unimaginable, and now we're only limited by imagination. All these things are real and here to stay, and we need to figure out how to use those tools to build amazing experiences. So thank you so much, and if there's any questions, happy to answer. And yeah, thank you so much, everyone.
Hey, I have a question. Can you guys hear me?
Yep.
Okay, great. So let me just start by saying thank you for giving this presentation. It's really cool stuff. So my name is Ryan. I'm a master's student studying computer science at Columbia. So what would you say was your biggest challenge, you know, coming out of Columbia with your master's degree and wanting to start this company? What was like one of the biggest roadblocks or hurdles you had to overcome?
So specifically because I did the computer science program, a lot of people will tell you, oh, you're trying to start a business, you want to start a startup, you need to have an MBA or you need to be like a non-techie. There's a lot of, let's say, preconceptions of you being a techie that you can't run a company or you can't understand the business metrics of a startup. I believe that's not true. It's obviously case by case, but that was a really challenging moment for me, for someone who actually loves technology, one, being underestimated, and even when and to be honest, like they were right in some capacity. Like I had to transform myself from that engineer at Columbia to be a business leader and like understand the unit economics of our business and a lot of things that you just don't get to study at like engineering, right? But these things exist, and like there's so many amazing success stories of founders coming out of engineering and coming out of like the CS department specifically at Columbia even. So yeah, so that definitely drove me into like, this is real, this is an achievable goal, and if this is my dream, I want to pursue it. And the results speak for themselves.
Thanks a lot.
Love it, thanks.
Hey, Alon, thank you so much for presenting. I have a question.
Yeah, talk to me.
So it seems like a lot of what you presented were sort of specific applications of AR and VR. And it seems like maybe the way that they will be marketed or commercialized were specific to that application. And so I wonder if you know, maybe it's the case with your own company, of sort of more robust, products where you can use AR or VR for all sorts of different things, and not just for like one specific application?
Yeah. So there's two things to say about this. One is that AR/VR it's a tool. It's like asking people like 10 years ago, what do you need a website for? And now it's obvious. It could be a marketplace. It could be a social network. 5 years later, people would ask, oh, what do you need an app for? And now it's obvious, ride hailing or like payments, stuff like that. Same thing with AR/VR. Like it doesn't stand alone. Like it's a tool for a use case. Like you're gonna have to build something with AR/VR. And that thing, again, could be any one of these use cases that we talked about. That's how I look at these things, like very similar to web and mobile. In general, but we went, like our approach was doing a generalist thing, right? Like we created a dev tool, a tool for creators and developers to build whatever they'd like. The same way if you're building a website, then you use some cloud to store images and videos. So tools like that exist, obviously. We are one of them, almost like a use case agnostic, camera agnostic tool that you can use to build whatever you'd like. But at the end, if you're trying to, even from an entrepreneurial perspective, if you're trying to solve an issue, like solve a problem, you have to define that problem, and that problem is probably somehow correlates with some use case. From my perspective, as you saw with our entrepreneurial journey, that problem was a problem for developers, for creators, and that's what propelled us forward to build a dev tool. That could definitely be the case. That the same thing I had in my master research. We found a problem with physicians, and we were able to use AR as a tool to enrich the surgical environment. Hopefully that answers your question.
Yeah, great. Thank you so much.
Sure. Love it.
Hey, Alan. I have a question as well. Thank you for presenting today. It was really interesting. So my question is, since you moved from an academic research thesis to a company which solves a use case, how did you go about coming up with the right use case for you?
Right.
Yeah.
Oh, that's a good question. So that's the entrepreneurial 101. You start talking to people, and you talk to as many people as you can. At the beginning, we started with one idea, and then we started to talk to people like, would you use it? Do you need this? We had a hunch. We had some intuition because I had that problem as a developer. Maybe that problem isn't just my own. So you need to do what people call customer discovery interviews. You talk to as many people as you can and see what resonates well with them. We started out with something in the beginning, and then we realized, oh, that feature that we have in the product that we think we need to build, that feature is actually the product. This is the thing that people really, really wanted. So we talked to as many people as we can, and then that became echoAR. That became that cloud platform to stream 3D models and share them anywhere on the planet. And I advise you to do the same. If you have an idea for a startup, talk to as many people as you can. Startups don't exist in a vacuum. I think a lot of the bad advice that people get is oh, if you have a startup, don't tell anyone, they're going to steal it. That's never the case. Never, literally never. If you have an idea, it's probably contextualized in your background and what you know and how you can achieve that. And you're going to be the best person to actually make it work. You should talk to as many people as you can to get feedback and understand what is going on and what is not. Startups at the end is just evidence-based entrepreneurship. In order to get evidence, you just need to talk to as many people as you can. In addition, I'll just add to that, there's amazing resources for you specifically as Columbia grads to utilize. So for example, there's NYC Media Lab is an organization that's a consortium of all the universities in New York, like CUNY, Columbia, NYU. They throw out grants for students like yourself if they want to build some startup. We got in the beginning a $10,000 grant to build our startup. After that, there's we got a grant from Y Combinator. There's so many tools that you can that are basically open for you. City Hall is funding a lot of grants for developers who want to build stuff. Utilize that. You are in a heavily entrepreneurial city, New York. You're in a heavily entrepreneurial school, Columbia. There's so many resources like Columbia Engineering, Columbia Entrepreneurship that are there to help you create something. And if you're not even sure what that thing is, these are experts that can help you, and you can utilize your skill set. And I would also say, if you're a techie and you know nothing about, you have no problem to solve, and you just want to continue being that product lead on someone else's problem, no worries. There are so many, like how I was almost matched through my research to people doing medical research. What do I know about medical research? So you can do the same thing. People at all these, specifically Columbia, there's so much human capital of people who are trying to solve a lot of problems. They need your skill set as an engineer to build it. Hang out with people in other departments. Hang out with people in there's all these different meetups that Columbia does, and Columbia Engineering, I think third Thursday or something like that. Columbia Entrepreneurship is doing these things. Go to these things, connect with fellow entrepreneurs, and together build something.
Thank you. Thanks.
Yeah, sure.
Just one last thing. So in terms of courses which would be helpful to get into the space, which ones would you suggest besides?
So yeah. So I did the graphics track in the beginning, even though ML is like all the rage in AI. I did graphics at my master's, but then I transitioned to like a thesis track, specifically with Professor Feiner at the Computers, Graphics, and User Interfaces Lab. He has like amazing courses around about AR, VR, around UI, around human and computer interaction. Lydia Chilton is another professor that has really cool like research around that. So just check that out. Also shout out to Carmen Alvezio, who's like a staff researcher at that lab. Connect with him, he'll hook you up with like amazing things. And they have all these headsets you can play around with and like immerse yourself in that. At the end, people are looking for projects to be built. And if you're an engineer, you can help them do that. So check out those classes, the computer graphics ones and the specifically ones for UI design.
Thank you. Thanks.
Sure.
Would you say systems classes would be helpful for this kind of stuff?
It can be if you want to go to like the hardware route. So systems could work. I was always like a software kind of guy. So I went to like, I want to see how the graphics, how you render and whatnot. I think systems could work. I had also like extensive knowledge of like networks and computer networks and stuff like that and cloud. So that also worked pretty well for me, obviously building a cloud company. But yeah, try to find, I think one of the things that are overlooked is like in entrepreneurship specifically, and like when you choose your classes, find that thing that you have the most, let's call it like founder market fit, like the why you. When I tell our company story and I talk about like my project at Columbia, my interest in AR, VR, my background in computer networks, like it's obvious that I'm doing what I'm doing, right? Like what else can I do? With you're an entrepreneur, try to fit that niche. Try to fit that founder market fit, that it's obvious that you're the person who's building what you're building. If you're super into systems, look into how that correlates to augmented virtual reality or headsets or hardware and run with it.
Got it. Thanks.
Any other questions? We're a bit on time here.
I'd love to ask you one if we have time for one more.
Yeah, sure. I'm here.
So yeah, this was super informative. You're clearly super passionate about this stuff. I actually thought I recognized you from a Columbia Startup Lab video. When we were sending in our application. Yeah.
Love it. It was definitely probably me.
And I wanted to ask you, so what was the experience going from academia and research to just practical applications in software development? Yeah. And then also when you were talking about, you know, VR now needs a space on the cloud. What kind of files do you host? Like, is it only Unity, or do you target a specific subset? And then, you know, do you get any inspiration from other CDNs?
Right. Okay. Amazing questions. So I'll start with the latter. So we host that's one of our major value props, that we can host any file that like any 3D file format. If it's OBJ, FBX, GLTF, and then our cloud will automatically convert all of them to all of them. So if you throw in some object that works really well with Unity, we'll automatically make it work on Android, iOS, magically Pollens. And when you query that from our cloud, that will automatically work, basically. You can literally press play in Unity, suddenly 3D files appear out of thin air. And when it comes to the CDN components, so we're actually a middleware. So we sit on top of public cloud. So if you want to have your storage be on AWS or GCP or use a CDN like Cloudflare, you can still do that with our tech. We just make sure that the files and the 3D conversion works. And we also do a lot of optimizations. If you think about it, if your internet is laggy and you're watching a video, suddenly the frame rate reduces, the quality reduces. What is that in 3D? So what we figured out is, like, in our cloud, you throw in a 3D model, we convert it to different file form. Like, we do polygon reduction, we reduce the number of polygons for every 3D model. And then we have like all these versions. So if your internet is laggy, let's send you the lower version, like the low quality version of the 3D model. Or another challenge that we're trying to solve, if you have a 3D model that, I don't know, the entire city of New York, and you want to stream that to the palm of your hand, do you have to stream the entire model? Like, obviously not, because it's like super small. So these are really cool technological challenges that we're trying to face and trying to figure out like what people already did for like existing CDN and cloud solutions that we can almost like transition or transit into AR, VR. And I think that's very similar to what happened in the past. Again, I mentioned what we saw in web, how it transitioned into mobile, and now we're trying to transition web and mobile to 3D. And I'm sure tomorrow there's going to be like something else that I can't even imagine. Your first question was, I already forgot. Can you repeat that?
I think it was the academia to.
Oh, yeah. So that transition was hard. Like at the beginning, being an entrepreneur is really hard. Like it's building your business. It's 50% of it is storytelling, understanding how you convey your message, how you bring investors on board, how you bring clients, how you bring team members. You're getting so many punches all the time. Like all you want to do is just like relax, but you can't because like everything's on you. My point again, my research was very, very illuminating. Like that was the thing that brought me into that world of AR. I was able to pinpoint a specific issue. The number of servers that I had to hook up in that project was unbelievable. And then I was like, hey, there's probably something here. It's probably not only my problem. So I definitely say use the research as something to find what you're passionate about, but also get that, that proof stamp of approval that you're an expert where you're doing. Like obviously when I talk to investors and I'm telling them to have a master's at Columbia and I did this research, yeah, like I don't have to like continue talking for them to believe that I know what I'm talking about. Again, going back to that founder market fit, I see a lot of founders pitching their idea, pitching their startup, but it's unclear why they are like the perfect match for it. As opposed to like really successful startups that I hear a pitch and they're like, oh, obviously this guy or this girl are doing this because this is what they're born to do. And that is the thing that you want to inspire your people to that. And again, you can get that through research. Like you can build something and expand on that later once you finish your program.
Thank you so much.
Sure. Any other questions?
Yeah, I have one second quick question following up on what Ryan said. So is there any particular material, like, some sort of guide or book or article that someone sent you when you were trying to actually become adept at starting a business that you found helpful?
So I loved, again, all these entrepreneurial programs that we went through, if it's Techstars, if it's the NYC Media Lab program, if it's the R Lab program that is all about AR, VR, check out the R Lab Accelerator. Again, it's another organization in New York. All these things, these were like my boot camps into injecting myself into this entrepreneurial world, like making that switch from an engineer to an entrepreneur. I literally had to switch professions, and like all these different entrepreneurial courses or programs helped me do that. Because like Techstars, for example, was a transformative moment. All they do is talk to you how you can make a really good business, how you can build a startup, how you can build a company. That is something that, again, like you have to learn. When it comes to specific books, actually during this weekend, I read a really cool, really short book that has an audiobook on YouTube called The 5 Temptations of a CEO. It's really short. It's just about like, if you're CEO of a company, what can you do not to fail? Other books that I can recommend, there's another book called What to Measure that's all about KPIs and like key performance indicators about your business that you can check out. But again, I think for me, as someone who doesn't actually like to read books and loves to be immersive, like spend an hour in VR, the grunt work of like going through customer discovery interviews, talking to as many people as you can. I learned so much from just talking to people and showing them my slide deck or product or whatever, like the first version of the product that I could have ever learned from any book. Like you have to talk to as many people as you can. There's so many resources out there that their entire job is to help you. Think about investors. Like, what do? These investors just sit around, wait for you to come to them and give them the opportunity to invest. Like, that's all they do. And that's a phenomenal thing. Like, there are people out there that all they want to do is to support you. Find them, talk to them as much as you can, learn from them. We model our business model for like other companies. We did the research, see what they made. I think that's a little more effective than like a book. Even though, again, these books exist and some of them are really fun, like the ones I mentioned.
Thank you, Alon.
Oh, and there's another book by Techstars called Do More Faster, I think. It's really, really good. And that goes, or another one about the deal something, venture deals. Venture deals, if you want to learn about VC structure, like that's the book for you. And that is something, again, they don't teach you at Columbia. They don't teach you at college, at least for not in engineering, because like, but these are pivotal things that you have to understand in order to raise money. You need to understand how a VC firm is structured, how a fundraising process works. So these are good resources. Any other questions? Again, I have my email here. Feel free to reach out anytime. Any question, as you see, I'm very talkative, happy to talk about anything. So feel free to reach out. Thank you so much, Ivy, for facilitating this and for inviting me to speak. This was an amazing, amazing time. Thank you all, everyone, for being here. Stay safe and healthy, and keep crushing at Columbia. It's like the best place on earth. Yeah. So thank you so much, everyone.
Thank you
Thanks,
for
Alon.
this presentation. As Sophia said, your passion for AR, VR, and the industry definitely shines through. So it was great to hear from you and to have you back as an alum. But thank you, everybody, for joining. As I said at the beginning, it's always great to see familiar and the same faces again. So please feel free to join the rest of the calls throughout the summer. And again, with the demystifying the dissertation, we'd love to see you guys in those discussions as well. But for today, thank you so much, Alon. And I know that we will definitely focus a lot more on maybe introducing more AR and VR into some of our work at Columbia.
Love it, love it, love it, love it. Thank you so much.
Thanks again. Have a good day.
Bye, everyone. Thank you. Have a good one, y'all.